The University of North Carolina at Chapel Hill is a public research university. UNC's Energy Services provides efficient and reliable utilities to the UNC campus. In more detail, it maintains and delivers utilities and infrastructures for services such as electricity, water, wastewater, reclaimed water, stormwater, chilled water, and steam, as well as the purchasing, generation, distribution, and energy monitoring of these utilities and infrastructures. There are 4 major systems within energy services, including chilled water, steam, electric distribution, and water. But today we will be diving deeper into our chilled water services. What is chilled water and what do they do? The district cooling system, which consists of a network of chiller units and underground piping, provides chilled water that is utilized to cool buildings and equipment across campus. The main goals of chilled water systems are to produce enough chilled water to meet the campus cooling needs with 100% uptime, to produce chilled water as efficiently as possible to minimize electricity and water usage, and to plan and prepare for future campus cooling needs such as new buildings and renovations. In order to understand the chilled water process, let's look at the whole process in 3 cycles. The chilled water cycle, refrigerant cycle, and condenser water cycle. All 3 cycles are completely separate, only connecting through heat that is transferred between them. The diagram shown here was drawn by Lee Baker, the chilled water systems manager. Starting at the cooling of the buildings on campus, chilled water cools the outside air that is distributed throughout the building. This chilled water then needs to be recooled and will make its way back to the chiller water utility plant. Here, we move to the 3 cycles of the chilled water process. First, refrigerant absorbs heat from the chilled water, thereby cooling it again for redistribution to the building. Condenser water then cools the now warm refrigerant. Finally, the warm condenser water is pumped to the cooling tower and cooled by air through evaporation. UNC's chilled water system is composed of 4 interconnected chilled water plants with about 27.5 miles of underground distribution piping between them and campus. Seen here is the 5 million gallon thermal energy storage tank used in the chiller process. The chilled water and condenser water must both be chemically treated in order to maximize the life expectancy of equipment, maximize efficiency to keep power consumption low, and keep water clean to prevent downtime for cleaning. What would happen if we didn't treat the water? Well, in this case, power consumption would increase, there would be a lack of heat transfer, corrosion, fouling, and microbiological growth would form, and overall, we would be unable to cool campus. Here at UNC, we have a commitment to sustainability. With 97.5% of the world's water being salt water, there's a limitation of fresh water that we must deal with. One important way this is fulfilled is with the use of reclaimed water. Reclaimed water is a highly treated wastewater that is used for non-potable water applications like flushing toilets, irrigation, and for cooling towers. UNC's chilled water uses around 200 million gallons of reclaimed water annually for cooling tower makeups. Additionally, specific chiller strategies are utilized to analyze performance of all 4 chillers, compare efficiency figures, operate the most efficient chillers, and operate with cold condenser water when possible, thereby saving money, energy, and resources. For example, in the winter, the chillers don't need to work as much because the outside environment can cool down the water on its own in the cooling tower, saving money and energy. On the other hand, in the summer, when it is hot and humid, the chillers have to be run a lot more. Another way UNC chilled water services saves a lot of money and energy is through the variable frequency device, or VFD. It takes less energy to run 2 motors at half the speed than 1 motor at full speed. Using this knowledge, the VFDs are programmed to use less electricity, which then saves money. VFDs have the ability to slow a motor down by sending less energy to it. These motors can be in chillers or the fans of cooling towers. Why is chilled water vital to campus? Chilled water services cools buildings and equipment to meet the university's ever-changing demands for teaching, research, medical, and administrative facilities. Chilled water serves 150 buildings across campus by use of 4 central interconnected chiller plants.